All right, so piecewise practice. We're going to look at the algebraic part first, then we'll look at the graphical part second. So here's how this works. You're going to see something that looks sort of like this. Evaluate, and then there's going to be at least 2 expressions here, if not 3. So to get where we want to get, our first job is to look at the if statements. Sometimes the word if will be there, sometimes it won't, but it still is going to mean the same thing. And what's going on here is, what's in the box tells me which expression to use. Because what I'm going to be given in a situation like this is I'm going to be given an x value, as you can see the 5 written below, and it's my job first to figure out where that x value fits, because it's only going to fit into one of these. And the way I figure out which way it fits, or which one it fits into, is looking at my if statements and plugging this number in. So for instance, on the first one I plug in 10. Is 10 less than or equal to 4? No. Is 10 greater than 4? Yes. So since 10 is greater than 4, I go to the expression next to that if statement, 2x plus 7, and I'm going to plug the 10 in where the x is at. And then just answer it. 27. Now, if I could see a graph of this piecewise function right now, I'd be able to just follow in the graph to where x equals 10, and I'd go up, ooh, y equals 27. I'm done. But we're not there yet. We'll get there, though. And we just kind of keep doing this for all the x values that they give me. Okay, negative 1/3. Is that less than or equal to 4?
Yeah.
Yeah. So I use the expression next to it. So I'm going to plug in my fraction. Don't flip out. Don't turn it into a decimal. Because again, with our LCD practice now, it should be easy to take care of this. 3 times negative 1 is negative 3. Divided by 3 is negative 1. See, fraction went away. No calculator needed. I owe my friend $1. I borrow another $1. Now I owe 2. But it all comes down to the if statement and figuring out which one it goes into. You can't just do both and say, well, you just pick which one. No, one expression per problem. So last one we're going to do up here, because we're going to get some more practice. Okay, x equals 4. Does that fit into the top or bottom if statement?
Top.
Top, nice. Because 4 isn't less than 4, but it is equal to it. So we'll go ahead. We'll plug in that 4 where the x is at and get that solved for. And we're ready to go. So nothing too bad as far as this goes. Okay, again, it's algebraic. So is it always just going to be one function like this? Of course not. We always have to expand ourselves a little bit here. So down here, now we have 3 functions we're working with. F of x, g of x, and h of x. So when I'm doing this first, I need to find the correct function. I need to look at the letter in front to tell me which one I'm using. Then I need to look at the if statement to figure out which statement I'm using, and then I go ahead and evaluate. So we'll start with a couple here, a couple of f's. So we'll be dealing with this guy. F of x, g of x, and h of x. F of x is one function. G of x is one function. Okay, and h of x. Yeah, there's only 2 in each one. You're right. Gotcha. So on 1, again, I look at my if statements first. So that f of 2 is the same thing as saying x equals 2. So if x equals 2, is that the top or the bottom? Bottom, because 2 is greater than 0. You're like, okay. So you write the 2 and you're like, well, where do I plug the x value in? I don't. Sometimes I may just be given a number here. So it fits in, I write the number, I'm done. Weird, but true. So on any of my f functions, I still go looking to see, okay, x is negative 4. X is negative 4, top or bottom? top, because negative 4 is less than or equal to 0. Again, the arrow's pointing at it, that's less than. So I look, it says 3, I write 3. I'm done. Okay, not bad. So let's actually do one where we can plug something in here. So we're going to move to g of x. Okay, here's my g's. If x is 7, top or bottom? Bottom, because 7's greater than 3. So I'm going to plug in my 7 where the x is. 14 minus 1 is 13. Okay, not too bad so far. Okay, one more here. We'll go ahead and do 0 here. Which one's 0 fit into? The top one, because it's less than 3. So I plug in the 0 where x is at and get my answer out. But again, it always depends on the if statement. All right, last challenge here. Let's see if I can squeeze all of this on. Ooh, I can. Okay, again, look at your ifs. All right, number 9, negative 4. Ooh. Ooh, we have dissension for the first time.
Hold on, let me. Yeah, it's top.
Okay, negative 4 is less than or equal to negative 2. Now, if you start to wonder sometime, you're like, I'm not sure. Give yourself a quick sketch. And you're like, okay, well, less than means left. Oh, yeah, negative 4 is to the left of negative 2, so it's less than. Okay. So 1/2. Plug in my negative 4. Right, half of 4 is 2. So negative 2 minus 4, be careful. I owe my friend $2. I borrow 4 more. I'm going to owe him more. I owe 6. One last one before we get to the graphing fun, the graphing party. 11. Negative 1. Where do I go? Bottom, because I'd rather owe my friend $1 than 2. And negative 1 actually is to the right of negative 2, so we're going to use the bottom one. But here I have to be careful as well. I've got to follow order of operations. I can't do 3 minus 2 and then multiply it by negative 1. That doesn't work. Multiply comes before subtract does. So negative times negative is positive 2. And I get my answer that way. Questions on the algebra way of doing piecewise before we go into graphing?
But how is that a positive? There's 3 minus 2.
Okay. So if I look at this, I'm multiplying these two values together. So yeah, that's the negative times the negative.
Where's that 1/2?
The 1/2, because since negative 4 is less than negative 2, I'm plugging it into this one.
Oh, number 9's for that one?
Yeah, because it's h. My h function on that one.
I've just been going the ones that are good.
Gotcha. Yeah, the letters, we got to make sure the letters in front match up to the functions.
Is 12 negative 9?
Would 12 be negative 9? Let's see. 6 would be greater than negative 2. Yes, it would be. All right, so graphing. I fought myself on this because I've actually taught this 3 different ways. I thought about teaching all 3 different ways to you, and I'm like, yeah, that's going to cause a problem. So instead, what I've decided is I'm going to go with what I think is the best way of the 3, but I'll sprinkle in some shortcuts here that you can use if you're comfortable graphing lines. But I just get this feeling if I go to just strictly graph lines and erase, we're going to have a problem. So here's how we're going to do it. Okay. First, we're going to graph a line on your graphing calculator. So, if you have not done this in a while, or maybe ever, here's how this works. We're going to hit y equals first. That'll pop up this screen. It's where I plug in my equations. I'm only doing one at a time. Don't do them both. So I'm going to type in my first one. So 2, the x is this funky button up here next to alpha, the one with x and t and theta and n. Just gives you x. It's really not that special. And then I got to make sure I use -1. If you hit -1 instead, you'll get an error message. So 2x minus 1. And if I hit graph, Graph the line. Well, that's super. How's that help me? I need to graph the line. Here's what we're going to use. Yeah, we're going to hit second graph because we want the table. Because here's how this is going to work. This tells me where I'm going to start. So I'm going to start where x equals 1. But then I got to look at the inequality. This says x is less than or equal to 1. So if I start at 1 and I start going to less than, what are the next couple of numbers that are going to show up? If I start at 1 and start going left, 0 and -1. So those are the three x values that I'm going to use to make my line. So I go to the calculator. I'm like, okay, let's see where x equals 1. So when x equals 1, y equals when x equals 1, y equals 1, excuse me. I'm going to plot that point, 1, 1. I'm going to make a little dot. Don't make huge dots right now, just little ones. And then I'm going to go to 0. 0 says y is -1. And then I'm going to go to -1. It says y is -3. You're like, okay, so what? I got 3 dots. So once I get the 3 dots, I'm starting at 1. Okay, so I'm starting here. If it's or equal to, I'm going to use a nice big closed dot to show the or equal to. So I'm going to like jumbo size the first dot. And then to finish, I just start from the original dot and connect it to the other two. Draw a line through it. So it's like you're graphing like part of the line, because if I look at the graph, it looks like it goes all the way through. But piecewise tells me where my line starts, and depending on if it says less than, okay, if it says less than, I graph to the left. So we're going to do a little bit of notes to the side here. Okay, just stick with me. We're going to do like 3 or 4 of these. So we're going to jot a couple of things down here. Okay, my starting point, where my if is, if it's just greater than or less than, I use a nice big open circle. If it's an or equal to, I use a filled in circle at that point. Okay, and that's only at where my if value is going to be. Now, if I'm trying to figure out which side to graph on, the points will help me. But if I'm trying to figure out, the graphing portion, if I have x is less than, okay, I'm going to use points to the left that I'm going to graph. So notice here, we had x is less than 1, and the points I connected went to the left. If I have greater than, I use points to the right. I'll never have my arrows going the same direction, because then I'm not paying attention to the inequality part. But again, it's going to take a little bit of practice. So on the second one, okay, here's my if statement. This will always tell me where I'm starting. So I'm starting at 1. And then since it's greater than, I'm going to use a couple numbers to the right of that. So I'm going to use 1, 2, and 3. So we got to graph the second one. We're going to clear this out, put my new one in. Second graph, because I want to use the chart, and I'm going to plot these points. So let's see. So when x is 1, y is 4, little dot. When x is 2, y is 7. And when x is 3, y is 10. So get my 3 dots. And again, greater than, my dots are going to the right. I'm feeling good. Is my dot at 1 where I start going to be open or closed? Open, because it's just greater than. So we're going to make a nice big open circle there and connect the other two dots. And we have a graphed piecewise function. Weird, huh? So the biggest thing is going to be, as we do these, as we kind of bop from problem to problem, is just getting used to the theory of doing this. If I have people comfortable with graphing lines, you could graph the whole line and then just erase the part that you don't want to use. But I've found over time that ends up biting me when I try to do it that way. So we're going to try this and see how this works. Okay, second one. Let me go ahead and get this typed in. Again, depending on your calculator, I would suggest putting your fractions in parentheses. It's just safe. Because if you put 1 over 2x, you're going to get a different graph than I do right now. So I'm going to hit second in graph. I want my chart. Yes, sir?
I'm going to ask a typical algebra question. Where are we going to apply this in line?
Good question. Okay, let me pause here for a second where piecewise actually comes into an application. It happens quite a bit in business, actually. In business, if you are any type of a business that purchases products, whether to build your own or to bring in and resell, a lot of times if you go onto websites, it'll say like, if you buy between 0 and 10, it costs this much. 11 to 25 costs this much. They're actually piecewise functions of trying to figure out a cost versus profit ratio. We don't do a lot of those in the book right now because they get kind of technical the bigger and bigger that you bring them into. But that's the biggest application that you're going to get into with a piecewise function. I have another theory on the when am I ever going to use this question, but I'm not going to put the World Wide Web on a freeze for about 5 minutes as I do it. But I will explain that sometime. So, for what we're doing here, as we continue, if x is less than 1, so I will got my chart here. Besides 1, if x is less than, what other values am I going to be using? 0 and negative 1. Because again, if I start at 1, I want the next two values to the left. So, start at 1. Ooh, 1's at 0.5. Okay. Right in between there. For some of you, let me zoom a little bit here. It'll go out for a second, but it'll make it a little bit easier once it focuses. And then I just work my way through. Okay, 0 is 0. Negative 1 is negative half. But again, it's all about where I start. I start at 1. Is that going to be an open or a closed dot at 1? Open, because it's just less than.
So every time it's less than, it's open.
Yeah, if it's just less than or just greater than with no line underneath, it's always going to be an open dot.
So, like both, or just less than?
Less than or greater than. It's all about the or equal to. If we have the or equal to, that's when we have the closed dot. And then we just switch it up. So we take a sec, we get back, we clear, we, oops. Oh dear, that's not good. We got to be careful though when we're typing, especially with fractions, that you're putting them in parentheses.
No, I did it the same thing. When I type graph, it pops up like big graph is true, but my table is like
We're going to have to check into your table. Okay, we can do that.
x is negative 1, y is negative 1.
Now, wait, they might be seeing what's going on here. So again, if x is greater than, if I start at 1 and go greater, I'm going to the right. So again, those are the values I'm looking for in the chart. So 1, I go up to 2, little dot. 2, 1. 3, 0. And again, I'm starting at 1. They both will always start at the same number. But here it's or equal to, so it's closed. And then I connect the dots with the rest of them. There will be some times that those actually will start at the same dot. We'll probably end up seeing one of those here as we go through the rest of these. but nothing too bad. All right, so let's flip here. We're going to go to 15, and then I'm going to start working on some homework issues with you. We're going to skip some of the rest of this for now. So, all right, one more here on the back. Let me get my calculator up. Get this typed in. We'll get that cleared out. Second graph. Okay. So I'm going to start at x equals 3. And I want the values that are greater than that. So I want two values to the right. So 4 and 5. Okay, so 3, 5, 4, 6, 5, 7. And I go, okay, it's not or equal to, it's just greater than. So open dot at my starting point at 3 and connect the dots. And as you start doing this more, it's like anything else. It's going to suck the first time or two because you're trying to remember all the different steps. But as you do it, just like anything else, it's going to get easier and easier. X is less than. I want the next 2 points to the left. So I'm at, all right, so 3, 0. Oops, wrong way. 2, negative 1. 1, negative 2. Close dot at 3 because it's or equal to, because it has the line underneath. Look out. Bless everybody. And draw my line.
Why did you go that way? Or why did you do 3, 2, 1? I did 3, 4, 5.
Okay, on the bottom one, look, it's x is less than or equal to 3. If it's less than, I've got to go to the values to the left of that are getting less. Which one? On this? Okay, I can zoom a little more here. Sure. So our main focus today and tomorrow is going to get some practice with these and to also practice some more with the evaluate. So we're going to kind of do a 2-for-1 here. We are going to try out on the homework sheet. Let me get the calculator out of the way here. Can we still fit everything? Ooh, we can. Nice. Okay, so we get the homework sheet set here. So we're going to graph. I know it says without a calculator. Well, we're going to use a calculator anyway. So, just like we've been doing, we're going to go ahead. There we go. Whoa. Get our equation typed in. Get my chart up. Okay. We're starting our line at 0. So 0, x is less than 0. What are my other two numbers going to be? Negative 1 and negative 2, because we're going left when we're doing less than. So I go and I'm like, all right, swing this over. So we're going to be at 0, 3, negative 1, 1, and negative 2, negative 1. Okay. So that first dot is going to be at 0. The inequality will always tell me that. So it's this one. What type of dot is that going to be? A not filled in one. And then we connect the dots, and we've got that part done. So then, I just repeat the process one more time. 3 minus x. Second graph. And I say, okay, I see it's going to be a filled in dot because it's greater than or equal to. What are my other 2 points going to be besides 0? 1 and 2. So 0, 3, you're like, hey, it's the same point again. That's okay. 1, 2, and 2, 1. So you're like, wait, though, it's filled in. It's supposed to be open. Well, that's going to happen sometimes. So we're going to fill it in now and connect the dots. And that takes care of the graphing part of this. The evaluate part is just like we did at the start of the examples in the notes. I look at this part and I say, okay, 0. I plug in 0 for x. Which one's true, top or bottom? The bottom, because they are equal to. 0 isn't less than 0. Well, 0 isn't even greater than 0, but it's equal to it. So again, I plug in the 0 where the x is at. Get a numeric answer. It'll only work for one of them each time. Okay, -3. Is -3 less than 0?
Yes.
I was going to say, I'm going to pretend I didn't hear that. Okay, it's the top one. So 2 times -3 is -6. I owe my friend $6. I pay him 3 back. Now I only owe him 3. And then f of 2, that is greater than 0. I agree. So 3 minus 2 is going to get me 1. And I'm off and running on these. So your job. Yes, sir.
You said that only one would work for 3 minus 0 equals 3. But if you plug 0 for x in the top one, it would also get 3.
It would, and you're going to hit exceptions to rules, because if you look at my graph even here, since they both start at the same point, I'd end up with the same answer either way. But the only time that would happen is if my piecewise graph starts at the exact same point. So more times than not, that's not going to end up working out. But you're right, it does in this particular circumstance.
Hey, why did you put -6 plus 3?
Because 2 times -3 is -6, and I was just showing my steps.
And should those be equal signs in there after each one?
Equal signs where?
Before the 3, before the -3, before the 1, should those all be equal signs?
Yes, yes, and yes.
Okay.
These, yeah.
I wasn't sure if there was going to be.
Yep. Okay. So you're